Hello everyone to another day of pre-calculus review. Uh, Today we're probably gonna go over the problem when you start multiplying out polynomials by larger factors. So you've probably all had the problem of uh, 4x plus 3 to the third power. Well, I mean, technically, you know what this is, right? No, this is just 4x times 3 times 4x times 3 times 4x times 3. I mean, 4x plus 3. You know, this is just equal to this, right? But just because you know what that is doesn't mean that you can easily solve it. So when you actually have to solve problems like this, you end up having to multiply 4x plus 3 squared first, and multiply 4x times 3 to it. In this example, we get 16x squared plus 24x plus 6 times 4x plus 3. So you multiply this to here again. You have 64x to the third plus 96x squared plus 24x. And after that, you multiply the 3 to get 48x squared plus 72x plus 18. This is more or less what you end up with. And to clean it up, you have to do 64x to the third plus 144x squared plus 96x plus 18. That took a lot of work for what can be simplified down to something like 4x plus 3 to the cube. I mean cubed, right? So the rule that we can use to easily solve problems like this, or at least do them faster, is known as what is called the binomial theorem. Now, uh, to give you a to show you what it generally looks like, the equation looks something like a plus b to the nth power equals the series of k equals 0 that approaches n. For n, choose k times a to the n minus k times b to the k, with n choose k equaling n factorial over k factorial over n minus k factorial. And you might be like, yo, hold up, that's not simple at all. I would much rather do this than have to do all this. And I completely understand where you're coming from, because for me here, like, would it just looks like nonsense to me too. However, if you actually look at what each individual thing means, the equation itself is not that complicated. So first, let's start with the general things. What is a plus b here? A plus b is simply, for example, in the example we used above, a plus b, a would be 4x and b would be 3. This is just A plus B is just a representation of what's inside of the initial thing that you're trying to get to a certain power. And n is the power that you're trying to multiply it to. Now, let's go over this again. This is a series. To be exact, it's a series that, so with the starting point being k, in the equation, it plugs in k as 0 and increases k by 1 until it reaches n. And n is determined here, but essentially k goes up by 1, and you only count the integer 0 until it reaches n. And when n reaches k, the series stops. This n choose k thing, as we see here, is a separate thing that multiplies the n over k factorial times open parentheses n minus k factorial. And this part might trip you up, but what this is essentially is that if you think about it, k always starts at 0, right? And n is the goal you're reaching to. So n is going to start on will n, and until a becomes 0, b will increase until b of k equals b of n. This type of question is much more easy to understand once you have a clear example. So let's use the same function we did earlier, right? For x plus 3 to the third power, or cubed. So if we see here, well, a is equal to 4x, and b is equal to 3, n is equal to 3. So we take this binomial theorem over here. I'm just going to move this over here. We start plugging it in. So okay, it starts from 0. This is a given, and it goes until it hits 3. It is 3, choose k, a to 3 minus k, b to k. And when you write stuff like this out, you write them out something like 3 choose 0, a 3 minus 0, so just 3, and b 0. Plus, because you're done with the first thing in the series, you start on going on to the next one. Go here. 1, a 3 minus 1, so that equals 2. And b, well, we're on k equals 1, right? So this is 1. Should write this out as k equals 0, k equals 1. Of course, writing this out on the top is not necessary, but sometimes when you get to larger problems, writing it out like this makes it clear what the k is so that you don't get confused. 3, choose 2, 2, that's a 2, not a 3. A 3 minus 2 equal to 1, b to the 2, because k is 2. Now here we add 3 to the 3, 3 choose 2, that is not a fraction. Do not make that mistake and put it there. Don't be like me. 3 choose 2, a equals 0, b to the third power, and k equals 3. And you said earlier that a equals 4 and b equals 3. Let's start plugging this in, right? So 4x to the third power, and b is to the 0th power, so it's always 1, plus 4x squared b to the first power, plus 3 choose 2, not a fraction again, 3 choose 2, x 1 3 2, plus finally 3 choose 3, 4x to the 0, which is equal to 1, and 3 to the third power, which is equal to 9. Now that we've done that, we need to figure out what these choose 2 means. If we can bring this over here. Oh. And whatever, we can just write it again down here. And k equals n factorial for k factorial times n minus k factorial. Just as to other things, this is not as hard as it looks. What this means is, since n is always constant, n is always 3, so it just becomes, for here, it's 3 factorial over 0 factorial is 1. Remember that. 0 factorial is 1. If you don't remember this, always remember this. 1 times 3 minus 0, which is equal to 3 factorial. So 3 factorial over 3 factorial is 6 divided by 6. So this is equal to 1. Let's figure this out, this next one. N remains 3. K is 1. 1 factorial is still 1. 3 minus 2, so 2 factorial, which is 2. So 3 factorial over 2 factorial, essentially. And that just becomes 3. This is equal to 3. Going here, 3, 2, 1. As you can see, 3 factorial over 2 factorial is just a reverse of what we did here, so it's 3 again here. And finally, 3 factorial over 3 factorial times 0 factorial, which is equal to 1, so 3 factorial versus 3 factorial is 6 divided by 6, so this ends up being equal to 1 again. And we are almost done, but to finish writing it out, there is one more step we need to take. And that is, well, for 4 to the third power is 16 times 64x squared plus 16 times 3, 48, 48 times 3, 144 squared plus 9, 27, 27 times 4, 104 x plus 9. This is the final answer. To check our answer, we go back to what we had up here. Oh, this is 96, 96. Where did this go wrong? Oh, yeah. This is not 9. This should be 27 because, yeah. Anyways, that's the final answer. Now, you might be thinking, what's the point of doing this whole thing? This took way longer. This took like 20 minutes to do. And that's because, well, to be fair, I was explaining it slowly. Uh, the main concept of the binomial theorem itself is simple. Like, it looks complicated, but you see that it essentially, especially the take parts, it repeats itself as it goes as n reaches k. Uh, there's a point at which when n equals 0, I mean, no, when k equals 0, uh, n choose k is equal to uh, n choose n when k equals n. And now, but yeah, you might be thinking, wait, that didn't help at all. Well, to be fair, it's going to be a lot faster the next time you do it, but it also took longer because we were still doing a simple binomial, which we're doing something like to the third. What if you had to do something like 2x plus 1 to the 9? Are you going to multiply this all out? In that case, it will definitely take a longer time than doing this. That's going to take a ridiculously long time to do, and this theorem honestly helps you a lot when you try to solve it. Now, what you need to just some things that you need to remember here as a sort of a tip. Remember that it's a plus b. Don't think that b also always has to be this. B could also be x squared or even y. It doesn't always have to be x plus a non-variable in the second part of the term. And that's why although that's the whole point of like putting it like this. If we put it like this, say these were just y, then we just are able to replace this with y, and it still works out easily. You get like part that's actually partially why this took so long. If you actually do this with x's and y's, this actually works a lot better because you don't have to multiply all the coefficients. Essentially, what made us take so long on this problem is because we had a lot of coefficients that we needed to directly multiply out, and that's just simple math. So if you have a calculator, that's going to make it easy for you. And on most graphing calculators, or the standard one that you need to use for school exams, you are not able to, on a scientific calculator at least, the new graphing calculators, you can, like the TI Inspire, you can definitely figure out these polynomials, but the normal graphing calculator, you are unable to figure out how to do this. That's probably gonna be the end of the lesson for today. And I hope you have a great night.